Hey, in this episode, I thought it would be cool to check out HashiCorp's Consul product for easy service discovery. Consul is an open source tool that has a pretty active community around it. Today, we'll be chatting about common use cases, the high-level server architecture, how a service registry actually works, and more. This episode is sort of broken into two parts. First, we'll cover the theory around service discovery in general, then we'll look at some demos using Consul in action. Let's jump over to the ecosystem map for a minute and look at where Consul fits into the larger picture. So I see Consul falling into the service discovery category here. Consul is very much one of those behind-the-scenes supporting infrastructure type tools that you rarely interact with once you get it all configured. Before we dive in though, I wanted to sort of step back for a couple minutes and chat about the big picture of why you even need service discovery and what it is. Then we can relate this to the core use cases of Consul via a few diagrams and get a detailed picture of the problems Consul solves. So let's say you have two machines, a web server and a Redis content cache. These could be virtual machines, containers, or whatever. Now let's say you wanted to connect from the web server over to the Redis server. How do you do that? Well, in our web app, we need a way of knowing where the Redis instance is located on the network. If you're a smaller shop with only a few machines, you might just hard code this network address right in your web app, as it will likely never change. If one of these instances die, you just restart them, and they sort of always stay the same and have the same network addresses and ports. In a sense, this is sort of super simple service discovery, in that you want to discover how to connect to this Redis content cache. So to solve the problem, you just hard-coded the network address and port information. Maybe your website is becoming super popular and you need to add more Redis instances. This creates a problem though. Are you going to start hard-coding all these IP addresses in your web app? What if you need to take some of these offline to do maintenance? So you sort of get this idea, hey, I'm going to create a DNS record now where it sort of abstracts the problem. Now your web app will just do a DNS lookup and grab a listing of your current Redis instances out of DNS. Again, this is a form of super simple service discovery in that you're using DNS to find instances. This isn't super sophisticated, but it mostly just works. You also have a little more flexibility now as you're not just hard coding things. But this method has drawbacks too. First, you're manually doing things and it's probably alright for smaller sites with mostly static infrastructure, but as you grow, it'll quickly break. You're also probably using something like round-robin load balancing, so you don't have much control over where your queries are routed. If things fail, you might actually have to manually update these zone files to add and remove healthy instances. Also, some applications don't honor DNS cache time to live values. So you might have stale records hanging around and you might need to manually reboot things to sort of pick up the latest values. But for the most part, this just works for smaller sites, as the maintenance overhead isn't too much. Alright, let's crank up the complexity scale and get into the territory of where these more advanced service discovery tools start to make sense. Let's say business is booming now and you added a bunch of additional web servers to handle the traffic. You also added a load balancer in front of these web services so that you're now proxying all the traffic through this single point. Again, we have all these web servers connecting out to our content caches. In reality, you'd have databases, storage systems, content caches, and lots of other supporting services too. But just for ease of use in the diagramming, I'm just drawing a simple picture here. So let's say your company's adopted a container strategy. Your company's moving towards an environment where you want to have a CI/CD pipeline to deploy changes into your infrastructure environment multiple times a day. These little boxes here are meant to show that we're running container instances now. So now we have the ability to spin up lots of infrastructure on the fly and sort of closely model that to the amount of traffic we're receiving per day. This might mean we scale from 10 instances to 20 instances throughout the day. You'll notice here that we're using fairly random IP addresses and port numbers. This is because we might have multiple container instances running on the same physical machines, and so we're giving them random IP addresses and ports that are unused throughout our cluster. We might also have container instances failing or being restarted throughout the day, and this list is constantly changing. It's very dynamic. What about our web tier? Well, this is also scaling up and down throughout the day to model our traffic pattern. And our load balancer will need to know about all the healthy instances so it can direct traffic there. We're also giving random IP addresses and ports. Again, containers in this web tier list are constantly being refreshed as they fail, or maybe we're doing lots of code deployments throughout the day. This use case here isn't even that complex, but it's where things totally fall apart if you're trying to hard code address lists or use something like traditional DNS. Why though? Well, in a larger environment, with, say, thousands of nodes, new container instances could be spinning up and down in these various categories nearly every second. So if you're trying to do things manually or have things hard-coded, or if you have stale DNS records kicking around, it's going to become really painful, if not impossible, to keep on top of all this. We also need to keep track of not just IP addresses, but also all these random port numbers. You could track this via DNS serve records, but it's still not optimal. Also, it'd be nice to track metadata about these instances too. Things like what cluster do they belong to, what version number, are they healthy, etc. So this is where the more advanced service discovery tools come into play. I should mention that I've been chatting about containers here, but this totally applies to, say, running auto-scaling instance groups on AWS or something like that, in that you'll constantly have instances coming and going, and you need to keep track of them. Alright, so hopefully this paints a picture of why you might want to explore these more advanced service discovery tools if you're running a bigger shop. So, I mentioned as things scale, people need something like this. I just wanted to show you a few reference points that might give you a little context. So, as I was doing research for this episode, I was looking through GitHub pull requests for interesting bits. There's a pretty great thread here about a customer running multiple large clusters. There's one comment here where they talk about one of their medium-sized clusters running 3,400 nodes. So you can sort of imagine how you would totally need automation to handle this constant change with a server infrastructure of this scale. There was also a comment by Mitchell of HashiCorp where they say they have thousands of customers that are running this at scale, and they rank their largest console install at 36,000 nodes. So hopefully this sort of frames the episode and who might use something like this and why are they using it. So let's flip back to the diagrams for a minute. This here even seems like a really small scale environment when you compare it to running thousands of nodes and hundreds of different applications. So service discovery is the core concept of how do each of these applications find each other. We likely need to know the IP address, the port number, maybe some metadata about what cluster this belongs to, is the instance healthy, and all that kind of stuff. So this goes well beyond what DNS might offer. Alright, so that's sort of my take on Service Discovery 101. Now let's head back to the Consul website and check out some of the use cases. So Consul is a really useful tool for moving from a pretty small static environment to something like a cloud environment where all of a sudden things are much more dynamic. You might be using something like auto-scaling groups or containers, and instance counts quickly change throughout the day, and you need a tool to keep track of this. So here's the 3 core use cases that Consul is targeting. First, we have service discovery. This is basically how applications find other applications that they want to talk with. Next, we have this configuration component here. This is where you can store key value data in Consul that instances can ask for. I'll cover this more in a minute. Finally, we have this service-to-service tunneling feature. This is very much a Istio-like feature, which we covered extensively in episode 63, where you can configure your application to tunnel traffic through a sidecar proxy. This allows you to enforce policy, grab monitoring, logging, and all types of metrics about who is talking to who on your network. I just wanted to highlight that this service-to-service tunneling feature is commonly referred to as a service mesh. I just wanted to highlight that as when you say service mesh, it's not immediately obvious what that means. Alright, so to get a handle on how this works, let's flip back to a few more diagrams on how Consul actually works from a server architecture perspective. So we have our 2 servers again, but this time we also have a console server sitting on the network. Typically, you wouldn't just have one console server, this would be like 3 to 5 servers configured in a high availability mode. Consul is a client-server architecture, so you'll install a Consul agent on each of the machines in your infrastructure. Then these client agents will be connecting into the Consul server infrastructure. So each of these agents, after starting up, will connect out to the Consul server and sort of self-register, basically saying, hey, I'm a web server, please add me to the web server registry. Consul then starts tracking this node and service. Same goes for the Redis instance here. It connects, self-registers with Consul. You can almost think of Consul like a database that's just tracking lists of healthy instances on your network. Alright, so now when the web server wants to chat with the Redis instance, it makes a call out to the Consul cluster and asks for the healthy instances in that Redis service list. This is pretty much exactly how DNS might have worked, but Consul allows you to track instance health, IP address, port number, and lots of other data about the services you want to connect to. So this goes well beyond what something like DNS might offer. I've also mentioned health a little bit here. How this works is that each of these clients will be continually checking in with the central Consul servers. Consul will start to track the health of all these instances, and if you ask for something, it'll only return healthy instances. You can also define your own custom health checks too. Alright, so maybe things are growing now, and you add a few more Redis instances. You just boot them up and they self-register with the central Consul server, without you needing to do anything. Consul just adds them to our instance lists and starts tracking their health information. Then when we want to connect again, we just ask Consul for the latest healthy instances in our pool and we get totally up-to-date information. You'll notice this is totally automatic too, in that instances just boot up, self-register, and there's no manual work happening here. So what happens when a node fails? Well, the agent stops checking in, or maybe the health check will fail, and Consul will remove it from the healthy instance list. Then if we try to make a connection again, we'll only be given a list of healthy instances. Sure, you could get into a situation where things fail as you're talking to them, so you still need to deal with that type of stuff. But using something like Consul greatly decreases the chances of you connecting to an instance that, say, doesn't even exist anymore, or has failed a while ago but still hanging around in an instance list. So even though this is a super simple diagram, as you've seen on the GitHub page thread there, this works in practice with thousands of nodes and hundreds of applications. Also, this is why you need to run Consul in a highly available mode, in that this is pretty core infrastructure. If it goes down, you're definitely going to notice as your infrastructure can't look up healthy instances anymore. So let's jump back to the website for a second. So that covers the most common use case here, this service discovery piece. But what about this service configuration feature here? Well, since Consul has an agent sitting on each of these machines now, it sort of opens up a whole bunch of new use cases. Let's jump back to the diagrams and chat about that for a second. So our Consul cluster, besides just handling lists of services and their state, can also act as a key value store. You can store pretty much anything you want in here. Say for example that you wanted to track Redis connection settings, maybe max clients or a timeout configuration setting. So we want to make a connection from our web server over to Redis again. This time we ask the Consul cluster for all healthy instances, like before, but we also check the key value store for settings on how to actually connect. I know this is sort of an abstract concept, and this is just an example. Really, you can do anything you want with this key value store. But if you use Consul, this can sort of act as a source of truth for specific configuration data that might need to change quickly. Maybe you don't want to roll out or redeploy lots of instances just to push a simple configuration change. So this key value feature could sort of be a smart way of having your clients poll the Consul cluster for these types of settings. But this is just a general feature and you can use it any way you want. Alright, so that covers two main use cases now, service registration and discovery, along with the key value store. Let's chat about the final use case back on the website for a sec. This last use case is that secure service-to-service tunneling feature that is sort of like Istio but simpler. This is also referred to as a service mesh. Again, since we have all these Consul agents sitting around, maybe we could use them to tunnel traffic for us too. So let's jump back to the diagrams. So this last use case, or feature, is something called Consul Connect, where you can tunnel data through the Consul agent sitting on each of these client machines. This is a pretty advanced feature and it's still fairly new. I'm just going to add a third category of state data over here, called intentions. Let's check out how this might actually work. So far we've just chatted about use cases where our applications are talking directly with each other, like you might expect. But using this new Consul Connect feature, you can configure your application to route traffic through the local Consul agent sitting on each of your client machines. From here, the agent proxies your traffic to the destination agent, where it's then finally passed to the intended recipient. I covered the logic and sort of reasoning around why you might want to use a service mesh in episode 63 when we chatted about Istio. So if you're interested in that at all, I'd check out that episode as it adds way more context. But the high-level idea here is that you can now add policy enforcement through these intention lists. You can say things like, hey, the web servers can only talk with the Redis servers. Redis can't talk with anyone else, and the web servers can't talk with anyone but Redis. So when connections are being established, we can actually check this policy against the central Consul server and say, hey, should I allow or deny this connection? There's sort of pros and cons to this. You're obviously paying a performance price since you're tunneling traffic, but sort of on the pro side, you now have total visibility into who's talking to who, along with detailed metrics, logging, monitoring, and policy enforcement. By the way, this Consul Connect feature isn't on by default, but if you turn on this feature, especially in say a larger environment, you now have pretty much real-time information of who's talking to who. And this is likely really useful information from a security or auditing standpoint, so the performance price might be worth it. Alright, so let's jump back to the website for a minute. So this pretty much covers the common use cases, the client-server architecture, how service discovery and a service registry works at pretty much a high level. For a lot of people, if you're using a cloud provider today, this is already happening under the hood for you. You just fire up your instances, say you want a load balancer, and the cloud provider will do all this service discovery stuff for you behind the scenes. Alright, so that mostly covers the theory part of things. Let's jump over to the demos. So there's this console deployment guide, and it sort of walks you through setting up an example cluster. I've already configured one, but I wanted to quickly walk you through this. So here's what a console client-server architecture might look like. You'll have your 3 to 5 node console cluster down here, all sharing and replicating data, tracking things like instance lists, health data, key value data, intentions, etc. Then you have your client nodes up here. These client nodes could number in the thousands too. The general steps for getting this up and running are downloading console, installing it, configuring systemd, setting up your configuration files for either the client-server mode, and then starting console. Console is actually super simple as it's just a single binary for both the client and the server, and you just configure its mode and the settings via a configuration file, and then you get it running. So for the demo, I configured a fully functional 11-node lab environment with 3 console servers and a bunch of client nodes sitting in a Nomad cluster, used for quickly spinning up Docker containers. All these console agents are already installed and configured to feed data into the console cluster. I used that reference architecture guide and it went pretty smoothly. One kind of cool thing here is that you can see the architecture of our Nomad cluster and console cluster server nodes look very similar. That's because they're using exactly the same backend libraries for gossip protocol and leader election. This is a super battle-tested server architecture, and it's sort of a hidden strength of HashiCorp, I think, in that they share this library across different products. Alright, so if we jump over to the Google Cloud Console here, we have our 11 virtual machines running. You could honestly do this anywhere since we're just running vanilla virtual machines, but I just chose Google Cloud. So we have our 3 console server nodes here. Then we have our Nomad cluster nodes, where we can quickly spin up and down lots of containers and sort of test how console reacts to this. Nomad has 3 master nodes here, and then 5 worker nodes where we're actually running these container workloads. By the way, we chatted about Nomad in episode 74 if you wanted a refresher. But the basic idea here is that we can use Nomad as a super simple tool for spinning up lots of Docker containers across these worker nodes and sort of test the scale of things. I thought it might work for a cool demo. So there's lots of different ways you can actually interact with console. You can use a command line tool, you can use an HTTP API, you can also use a web interface. And there's lots of sort of libraries that you can integrate into your applications too. So here's what the web interface looks like, and it's already configured and it has a bunch of stuff in it. So here you can see a page listing all the services that we're tracking in our console cluster and their current health status. In this list here, you can see our console cluster, the Nomad master nodes, the Nomad worker nodes, a Redis example application that I'm running in some containers, along with an example web application that's also running in some containers. Let's check out this Redis service listing here. Oh yeah, you'll also notice these tags over here. So in addition to tracking things like IP address, port number, health information, we can also track tags and metadata about instances. So in our client agent config, we can add these tags. Maybe we wanted to track application version, whether this is a dev, test, or prod environment. Maybe we wanted to track the data center locations these instances are actually running in, or pretty much anything else. The kind of cool thing about this is when you want to do a console instance lookup, you can also filter based off these tags. So it can be kind of a cool feature, especially if you have lots of instances. Alright, so in here you can see our Redis cache instances running in our Nomad cluster. You can see what node the instances are running on, the IP address and the port, along with some health data. If we click into the health check here, you can see it's doing a simple TCP connection to make sure it was successful. But this is totally configurable and you can do anything you want with it. Alright, so that's sort of what the Services tab does. What about nodes? Well, Console is also tracking the health of all the agents running out on all of our virtual machines. So you can see we have 11 virtual machines running in our demo environment with 11 agents installed, and you can see all the health data here. You can also click into one of these nodes and get a summary of all the services running on that node. Let's pick one of these workers. So you can see all the health checks and all that. If we click over to services, you can see that we have our Nomad client, a few Redis instances, and this web instance. So this interface can actually be pretty cool if you're trying to debug something and want to know, hey, what's the state of a particular machine or the services on a particular machine. Next, let's check out this key value tab. This is where you can store pretty much any key value data you want to expose to clients. All they need to do is make a connection and ask for it. You can also see that I added a few example keys here. The next tab here is for access controls. Basically, you can define policy around who can connect, add, update, list, and delete things. So this might be good if you wanted to restrict what a particular set of agents can do or something like that. Finally, we have this intentions tab here. This is for that advanced console connect feature where you can sort of tunnel traffic from one agent to another, also called a service mesh. So this is where you can define policy rules for routing traffic if you want to enable that tunneling functionality. I'm not actually using it right now. I just added these sort of examples to show you what it might look like. And I just wanted to quickly show you what the Nomad cluster web interface looks like. So as we already chatted about, we have 3 Nomad server nodes tracking cluster state, and we have 5 worker nodes in here that are actually running our container workloads. So I fired up 2 example applications that sort of mirror what we were chatting about in the diagrams earlier. So we have a bunch of Redis instances. There are 10 running right now. Then we have an example web application with 5 instances running. So here's what that example web application looks like. So up here, I'm showing the host name of the container that's actually serving this instance. You can see that if I refresh the page here, the host name is changing. And this sort of demonstrates that load balancing is working across our container instances. The next block here is where we're connecting to the console server on the fly and pulling out some of that key value data. These values actually match what I entered into the console cluster earlier when I was sort of configuring this demo. Actually, why don't I just prove that this is working? So let's go over to the console cluster, and I'm going to edit some of this key value data. And then we can go over to the web server and verify that this is working. All right, so if we reload this here, the value should change from 25 to 75. Easy enough, right? And then down here, we're pulling the console cluster for a listing of healthy Redis instances. You can see that we have 10 instances here. All right, so to prove that this one is working, let's jump over to Nomad and change the instance count for our Redis cache. So I'm just going to edit the Redis cache workload here and change the definition from running something like 10 instances to 40 instances, and then let's save it. You can see here that Nomad is telling us what the change is going to look like. This is kind of a cool feature of Nomad in that you can sort of preview what's going to happen. All right, let's run it. Now let's flip back to our web application and start hitting refresh here. We should start to see the Redis instance list climbing here as container nodes are starting to come online. Pretty cool, right? These containers are coming online, self-registering with the console cluster, and then we can just run our little query on the fly and find healthy instances. Now let's go back to the Nomad cluster and scale things back to say 10 instances. Then let's save our change. Now if we reload the page again, we should see our list downsized pretty quickly. So this is what service registration and service discovery sort of looks like in a container environment running Consul. By the way, you can check out the sample web application over on my GitHub, but honestly, there's not much to it. I'm just connecting to Consul, grabbing the key value data, and then asking for a list of healthy services in the Redis cache list with the tag global, and then printing that out. Oh yeah, you're probably wondering how this self-registration works with containers. Well, let's quickly check out the job definition over on Nomad. So the Nomad definition has this section here where you can sort of define the steps for self-registering with Consul. All you need to do is define the service block here, give the service a name, add some tags, and then you can define your health checks you want. It's easy enough and it works pretty seamlessly with Consul. But honestly, there's tons of tutorials out there for getting this working with things like Kubernetes, virtual machines, and all other types of stuff. So if you have a use case, chances are someone's already done it. So this episode is already super long, and I wanted to show you some of the command line stuff of maybe interacting with the Consul agent directly. So what I'm thinking here is I'll add an additional episode in a little bit that covers a lot of this sort of command line tool stuff and maybe how to use the DNS server, just since this is already super long. Also, if you're looking for more information, there's some awesome online videos at the last HashiConf where they walk through lots of the latest features and stuff like that. There's also dedicated videos for each of the products, and there's tons of information here if you're using any of this type of stuff. Finally, I wanted to point out this learning site HashiCorp has. They define all the products here, and you can sort of pick what you're interested in, and let's choose Consul. From here, you can sort of choose a bunch of different online learning labs and sort of walk through all the way from the basics to super advanced stuff. So this is a great place to find hands-on information if you sort of want to learn about this. All right, that's it for this episode. Thanks for watching. Hopefully you found this useful. I'll see you next week. Bye.